All right, here are solutions to quiz 7 from Math 213. In this quiz, you're doing constructions, so you'll have a compass and a straight edge. I don't have those things because I'm on a computer, but I'll try my best to kind of describe what I'm doing. So what I want to do here is construct a ray that bisects the angle below. The way I'm going to do that is I'm going to first create points that are the same distance from point O. So maybe I'll write this over here, create points, I don't know, C and D that are equidistant, aka the same distance from the vertex O. So I'll put the pointy end of my compass here, and I'll kind of draw this circle here, and that will give me a point over here and a point over here, and maybe I'll call those C and D. And by the way I constructed them, I know that those 2 points are the same distance from O. All right, my next step is I am going to bisect this angle by drawing circles centered at D and C respectively with the same radius. You can choose any radius you want as long as that radius is greater than the distance from C to O or D to O, as long as it's greater than that distance. What I'm going to do is I'm going to put the pointy end here and the drawing end here and sort of create this circle going like this. And you might be like, you don't need the whole circle, you only need kind of these special parts of the circle. You're right. I really only need the part up here and the part down here. But whatever, I did my pointy end here and that gave me this circle, and then I'll put the pointy end over here and that will create this circle. I don't know why I chose to make these dotted lines, but I guess that ship has sailed at this point. And then I am going to, step 3, maybe running out of colors, make this blue. Connect the intersections of the red circles. So I have these 2 red circles and they intersect in 2 spots, up here and down here. And if I connect those with a straight line, that is not the prettiest straight line. Oh, that is definitely not the prettiest straight line. What I get is a ray. The ray starts here and kind of comes up in this direction. And I have now bisected that line. I guess that's good enough. I guess I'll call that good. You don't have to do it exactly like this. Your circles don't have to have the radius that I gave. They just have to have a radius greater than the distance from C to O, for example. But I think it's easiest to use these points so that your radius all stays the same. Anyways, that's part A. Part B, construct a line parallel to the line below that passes through the given point. Okay, what I'm first going to do is find, how about create a circle, draw circle centered at the point, intersecting the line in 2 different places. So I'll put the pointy end of my compass right here, and I'll draw this circle, and maybe my circle looks something like this. Fine. That gives me these 2 points. Well, that's a horrible drawing. Let's try that a little bit better. So I guess it would be more like this. My circle maybe would look something like that. Yeah, it's not a very good circle either, but I'm going to call that good enough. That gives me this point here and this point here. Line 2 times at maybe A and B. Step 2, construct perpendicular bisector to this line segment AB. So this is A here, and this is B here. And we learned that you can construct a perpendicular bisector by creating circles. Maybe put the pointy end right here and the drawing end here, and you sort of get this circle that would go something. Man, it is hard to draw circles on a computer. Something like that. And then you put the pointy end here and the drawing end here, and you get this circle that looks, jeez, that's terrible. Something like that. And you connect those 2 points with a straight line, and you get this perpendicular bisector. And yeah, I know that's a horrible perpendicular bisector, but we'll call it good. Keep scribbling on it, it's just getting worse and worse. But then you're not done, because you weren't asked to draw a line perpendicular to the line passing through the point. You're asked to draw a line parallel to the line passing through the given point. So essentially, I'm going to repeat those steps. I'm going to make this line a little bit longer. And then I'm going to say find points C and D on this new line that are equidistant from the original point. So I can do that by putting the pointy end of my compass here and drawing another circle. So that is a terrible circle. That's a decent circle. Yeah, I'm pretty proud of that. I'm not that proud of that. So I get 2 points, one down here and one over here. Maybe I'll call this guy C and this guy D. And my final step, which I guess I'm going back to red here, is construct perpendicular bisector to this line CD. So this point and this point, I can construct as perpendicular bisector. The way I could do that is I could put the pointy end of my compass here and the drawing end here and sort of draw this circle that swings out like this and kind of swings out like this. And then I could switch. I could put the pointy end here and the drawing end here. Sort of draw this circle and this circle. And if I connect those points of intersection, what I end up with is this line that is parallel. All right, number 2, I made a little change to this. What's going on is I have a bunch of people, Alex, Brian, A, B, C, D, and E, and A walked south for 3 miles, then walked east for 5 miles. It might help to have a graph of these things. So let's just suppose that they all start right here, and Alex walked south 3 miles, 1, 2, 3, and then walked east for 5 miles, 1, 2, 3, 4, 5. So here is Alex right here. And then Brian ran north for 9 miles, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's Brian right there. And in this problem, it's just asking about Chris, Brian, and Alex, so I'll ignore what happened with Derek. But Chris hiked west for 50 miles, so Chris is way the hell over here. Chris went way this direction somewhere, and then started going up north. And then at some point, here's Chris. I don't know exactly where, somewhere up here on this line. And the question is, how far north would Chris have to hike to be on, how far north would Chris have to hike north? Okay. To be on the line connecting Alex and Brian. So what I'm saying is if you draw a line between Alex and Brian here, eventually that line will get way out here to Chris. It'd be hard to picture, it'd be hard to draw the picture because it's so far out here, but maybe you can figure out where it would be. And the trick to figuring out how far north Chris would have to hike is recognizing that I have this right triangle here, and that the base of this right triangle is 5 and the height is 12, which ends up making this 13. That'll be a useful fact later on, but I'll leave that for now. We got 5 and 12. So if you think about how far we'd have to be to get to where Chris was, Chris, if you think about the distance between Alex and Chris, maybe I have to draw that in red here. Well, if this distance is 5 and we know Chris hiked 50 miles here, this distance is 55. And the question is, how far is this distance? This would be Chris's height. Well, how can I figure that out? Maybe you see similar triangles in here, right? You have this small triangle and you have this bigger triangle. Using similar triangles, the properties of similar triangles, I know that 55, maybe this should be in red, divided by 5 in green, has to be the exact same as this side length in red divided by this side length in green. So one way you could figure this out would be using similar triangles. If I multiply both sides by 12, I get C equals 12 times 55 divided by 5, aka 12 times 11, which is 132. So how far would Chris have to hike north? 132 miles. Long way. Okay, suppose that Derek wanted to be on the line between him and Brian. Derek wanted the line between him and Brian to be perpendicular to the line between Alex and Brian. So I'm going to try to reuse my picture. No, I'm not. Okay, so I have this same basic picture. I got Alex is down here somewhere, and let's actually put it to scale. So Alex went south 3, 1, 2, 3, 4, 5. There's Alex. And Brian went north 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's Brian. And here's the line between Alex and Brian. And Derek wants to be on the line wants the line between him and Brian to be perpendicular to the line between Alex and Brian. So the line perpendicular would be kind of this line, what I'm drawing right now. So since Derek started out going 6 in this direction, Derek is there, and I'm going to draw this line perpendicular, maybe not to scale. What I need to figure out, there's Derek, is what is this height right here? And the way I can figure out this height is, note that, again, from Alex to get to Brian, you have to go up by 12 and over by 5. So the slope of this line I could think of as maybe the slope of the AB line is rise, so positive 12, divided by the run, which is negative 5, so it's negative 12 fifths. So therefore, the slope, maybe in red, of the line between Brian and Derek should be 5/12, the negative reciprocal of this slope. So what that means is that every time Derek goes up by 5, he should go over by 12. But he's going to have a hard time going up by 5 and over 12 because this distance right here is 6. So I'm trying to figure out what this distance is. Well, I know that if he went up by 5, he'd go over by 12. So how much would he have to go up to go over by 6? I guess that would have to be 2 1/2. 5 over 12, which is the same as 2 1/2 over 6. So my answer to this question, I know that this distance right here has to be 2 1/2. And if this distance right here has to be 2 1/2, then because this entire distance is 9, I do 9 minus 2 1/2 to get 6 1/2, which would be the distance that Derek would have to walk north. Okay, this last one. Suppose that Elise calculated that she was 7 miles from Brian and 20 miles from Alex. Is she guaranteed to be on the line connecting Alex and Brian? Explain. Yes, she is. This is what's called the triangle inequality. And it says that if the distance from let's see, the two furthest away would be Elise and Alex. So the distance from A to E equals distance from A to B plus distance from B to E. So that only happens, maybe triangle inequality says that the distance from A to E equals the distance from A to B plus the distance from B to E only when A, B, and E are all on the same line. So the distance from A to E is given to be 20. And the distance from Alex to Brian, this distance here is 13. And the reason I know that that's 13 is if this is 12 and this is 5, 12 squared is 144. Plus 5 squared is 25. 144 and 125 is 169. And the square root of 169 is 13. That distance right there ends up being 13. So 20 equals 13 plus the distance from Elise to Alex was 7. Because 20 equals 20, the triangle inequality tells me these guys are all collinear. All right, I can sell in that here.